World. 1, 2, 3. I have my microphone on. Behold the flying orb. On the microphone arm now. I was shopping around for an adapter for quite a while until I realized I need an adapter from 5.8 to 5.8. The blue snowball already has the exact correct threading for my microphone arm, so it's much better than to put it on the table. Yeah, so I'm just gonna stream a little. I don't know who watches now or later or whatever. The YouTube chat is open anyway. And we make the Gazelle. It's called November Gazelle because it's being made in November. I think it's a nice name, November Gazelle. And it makes screenshots continuously and looks for patterns in order to understand what's going on the screen. And these green areas are recognized single colors. So this is all white, and Gazelle is smart enough to see that, actually. I know, it's incredible, I mean, yeah. But it's just the first step in a longer recognition process. And that will be really impressive, because we will actually find the text, and we will find the buttons, and we will find the scroll bars. With a very generic system. Here already we get a compression score. 70% means 30% got chopped off by replacing these areas with a short command. So the screenshots are compressed and they are analyzed. You can choose which screen to select. I have another screen here for streaming. No, streaming. I said it again. I'm still trying to learn the word stream. I always say scream. Yeah. It's not my first language, what can I say? Alright, so what am I doing right now? Sleep ending. Yeah, I'm moving the whole thing to a new way of handling threads, because I need the flexibility and I want to save some resources. We only make, we only make 5 threads on a 4-core system. 4 threads for 1 thread for each core, plus a 5th thread just to sleep. Whenever there's sleep required, like delay until the next frame is handled, or any kind of timed action, and we use a sleeper for it. And usually when you use Java timers, they will make a thread for each timer, and that's really wasteful. This thread just sits there and waits until the event happens. So we can, for any normal program, you can have one single waiting thread combined if you make the action quick. So the action part should be to only trigger, to put something in a thread pool. Yeah, these 4 threads are called thread pool. And we can also do something like using only half of a core. I have an on-off switch built in, not me, the software, which goes on and off 50 times in a second. And we can use this to reduce our CPU load to less than 1 core, which is kind of a feat. I mean, you can do this, I think, in Linux with a special tool. But in Java, for every platform, I think it didn't exist before, because we need to put little ping statements in the code. The ping statement says, should I sleep? If yes, it sleeps. If no, it doesn't. I explained this in the last video, actually. So I make these multi sleeper, and it basically needs to handle multiple target times and wait for the closest one. Yes, exactly. So we have this is the right data structure. Tree set with duplicates. I mean, you can just have a map, actually. Yeah, I guess that's easier. We have a multi-map which is sorted, and we go from the timestamp to the action. Bada boom. Because it's sorted, we always see what happens next. Entries, whatever. Yeah, okay, and then there's the API of this class, and this implements the iSleeper v2 interface that allows program code to sleep. Where are we? Where is it? What is it? Who is it? That's the public. And the user even gets an object that reifies the act of sleeping. So you can cancel it again. You can say later do this, but if you change your mind, you can say cancel or close, which is the same thing. We add it to the entries, right? Put target time and the action. This usual safety stuff. If it's null, then you don't do anything. If the timestamp is null, which is kind of, you should call this with a null value, but we'll handle it. We have it in the entries, and now the question is, did our target time change? That we should have a method for that. Next wake up timestamp. Next wake up time. Or simply wake up time. I like next wake up time because you can wake up multiple times. And this is simply the first key in this multi-map. Yep. And we should synchronize the whole thing, as any good citizen would do. So, I mean, let's just say check or something. General method that will see if we have to adjust our countdown. The base class restartable countdown is basically one of those timers. It actually does have this Java timer thing inside. But you can stop it at any time and say no, sleep until a different time. But it only remembers one time to sleep until. So that's the basis of our implementation. And just feed it with the right time. Where's the difference here? Okay, this takes a delay, this takes a time. And the time is in system time. There are two different times in Java. System time and clock time. You can really break a Java program, or if you change the system time while it runs, if it's badly written. I think my programs might suffer this. But all it takes is restarting the program. And how often do you change your clock time? Unless you're running pirated software that checks the system time. So long ago. Many years ago, you could cheat commercial software by changing the system clock time. So it thought it was not expired if it was a demo or similar checks. I think these simple tricks don't work anymore. I don't use commercial software anymore, though, actually, come to think of it. Unless it's some driver somewhere. In Linux, I am not using commercial software. Interesting. Paid for software, anyway. Okay, long rant, no meaning. What is this? Check set target time. Yeah, we have the next wake up time. Sure, next wake up time. Which may be null. And actually this is handled here with a 0, so and this is a bit stupid that this timestamp is in a different time. Timestamp is clock time. this target time is system time. Yeah, we can make this a method, of course. We can make the timestamp return system time. Does it do it? Does it do it? Does it do it? No, it doesn't do it. System. Have I ever done this? Comparing the sys clock. System. Is there a conversion function from clock time to system time? Interesting, I think there is not actually. Let's make that then. Clock time to system time. My machine is really slow. I think all the streaming and Gazelle is doing it. This Gazelle is like it's not honoring this 0.5 cores limit yet. And even just watching this thing here on YouTube is like 70% of CPU, 70% of one core, of which I have 4. Well, anyway. Maybe I'll close that YouTube window. I don't know. Or stop Gazelle. Boom. Not doing that much anyway. So we take the system clock, this one, and we take the other clock. That's our diff. And we can store that actually. This time diff. Oh, bad name, doesn't matter. Oh no, well, maybe we can use a better name. Up to system diff. Long. And it's just this subtraction. Clock system diff. And then this one's easy. Let's say if it's 0, we keep it at 0 because this is a special case in many instances, meaning no time. No. Clock time to system time. I believe that works. And then we just say clock time to system time of our date. We have a date? Wow. No, just in the program. Oh. So now we have timestamp.systime. Yep, set target time. If it's 0, it stops. If it's not 0, it checks if the time changed, and it starts the countdown if necessary. Oh, we need our next action anyway. First value increase. Action. Oh yeah, but we need to take it out of our list, of course. Haha. Otherwise this multimap will never get emptied. And the problem is I can watch myself drink coffee in the stream preview. Let's go. So no, we have a different action here, because what we want to do is start all the things. Yeah, there might be multiple actions at the same time. We want to start all of those using this one here. Entries. Yes, and we should synchronize actually. We should synchronize. So we get all the entries for the specified time. We call them, and we remove them. What if it stops itself? Does it kill the action if it's already in progress? Stop. Cancel timer. No, I don't think it does anything like that. Yeah, I think this code is pretty sane actually. But this order is wrong. Did you notice I removed first and then I get the entries? So that ain't working. And I think we should get all of the synchronization here. Okay, to call. That is a list. Variables to call. We remove. And we call. And now we schedule the next iteration. Start. No, I just checked actually. The check function does all this for us. I'm relatively confident that this makes sense. Not completely. Oh, and I put the internal method into the API area. That's not good. Let's put that up there. I did something with the bracket that was not good. But where? Where did I go wrong? Ah. Wrong order. Oh, we have to return one of these cool objects that define the sleeping process, reflect the sleeping process in code, in data. So let we make an instance of it. We put the timestamp in and the action and a close method, which is to cancel the sleep. Yeah. And we synchronize this one also. Remove entry, target time, and action, entries remove, target time, and action. Yeah, I wanted this for a long time. It's so unelegant to have like 17 threads in the Java system, all just sleeping. They take up resources. It's just not optimized, and who likes unoptimized things? We could do some very quick testing of this one here. How about we go to my lovely Java OS and test it. Do later. Do later. Let's make a nice method here. Do after, which is takes a number of seconds, not a timestamp. And we can implement it right here. Do later. Do I have this plus seconds? I think. I hope I do. Let's check the timestamp. Yep. Plus, also known as plus seconds. There. Okay. Yes. Do after. Let's say 2 seconds. And we say something cool. Applause. Let's see some applause. Oh, it's gonna be shown on the other screen, I think. I'm not fully adapted to 2-screen setup. Yeah, applause was visible on the other screen. Sadly, yeah, I'm trying to change it. I don't know. Doesn't matter. Print. Hello. Okay, that seemed to work. Let's say we close it. And we should not see any action. In fact, we don't. Now we sleep twice. Sleeping 2. And to make it hard, let's do 3 of them. One we put before the other timestamp, and one we put after, so it has to reorder them. And let's make one more at the same time. Timestamp is in 1 second, and we do this as well as hello 2, hello 2b, and number 3 comes after all of these. So now we should see 4 prints in a certain timed fashion. Is that correct? That's correct, right? Hello 2 to B came first, short delay, then hello and another delay, and hello 3, and it works. Yeah. Pretty good on first try. Now let's close the sleeper itself and see all the items be cancelled. Yes. Okay, I'm too lazy to put this in a stored test case, so I'll just leave it at that. Yeah, that was a first try effort. I mean, not that bad, right? Nice. So, okay, so the thread pool should have its attached sleeper. We just create one for the thread pool, for the thread pool. And we allow it to be retrieved. Sleeper, return sleeper. I also have quite a keyboard than last time. Quietest one I could find, except for the spacebar, which is kind of the loudest key. And here, ping source. I guess. Yeah, same thing. Also as a reference to sleeper object taken from the thread pool. So now we can replace some sleep statements. We can replace the general sleep statement with one that does this new multi-sleep approach. Here this just goes to the sleep function, and here we do the new mechanism, which has a ping source for every action that is run in the program. There is sleep forever, and there is sleep for at most a certain duration. We need this one is different case, I guess. This one you normally wouldn't do anyways. Sleep forever until you're interrupted or the program ends. That's a very unusual case. This one is the one we want, sleep a number of milliseconds. Please check the video resolution. What's up, YouTube? Why is it not optimal? I have 720p. 1152 times 720p. Is that the wrong one? Oh, it's supposed to be 1280. Am I scaling badly? Because this is a 16:9 display, so... Or maybe I put the wrong resolution in OBS. Yeah, that makes some sense. Maybe I'm actually squishing the image. I don't even know if we should do this one first. Maybe we should do the do later function. Just another way of sleeping. Do I sleep somewhere? Not really. Do I do later or do after? No, but somewhere. Somewhere I do. After I do the screenshot and the analysis of the screenshot, I go to a countdown to start the next analysis. Oh, and there's one more thing I guess we should do. If we give it a negative time here, I mean the time before now, it should be fixed. Maximum of this and the null timestamp. I'm sure the max function does not do what I want, but I have a smart way of making it do it. Static parameter type a extends countable a maximum of AB, and let's a compared to b. Yeah, just this a compared to b. Select a or b. Yes, return type missing. I pled guilty. Delete. Yes. We should test it again. Just a quick test. Hello 2B, hello 3, yes, correct. Oh yeah, we can test the other case also. Let's say timestamp minus 10 seconds. Oh, 84 degrees. CPU temperature, 88 degrees. ThinkPad is thinking hard. That does not really look right, actually. It didn't print the two others, did it? Wait, what? No, it's all good. Why is it printing some of the stuff up here and the rest only down here? Can someone explain this to me? Why this one print statement goes there and the other whatever. Just don't think about it. Don't think about it. Now I forgot where I was. Oh yeah, in the Gazelle program. Okay, yeah, this should count down. And I guess we just replace this with our sleeper. Countdown. Sleeping. It's now an instance of the sleeping class. That's decent. Let me say sleeper dot later timestamp plus yes, 1 divided by the FPS we want is our delay in seconds. It's going to be a timestamp. We have the target time already. Shoot and analyze. This stays the same. Good. Okay, we need the sleeper object, and we can say, give me the general global sleeper object. Yeah, it comes from the ping source. It's called ping version 3. New framework, static sleeper v2. Ping source. you can just create one of these sleepers, or in a good case, where we have a ping source, which every thread should have now, we get our sleeper from there. Let's try to compile. Yep, I have to recompile a library. A library. Yeah, then I want a control by which I can sample down the image, scale it down. For example, to 40p. Because that's one of the ways the AI will look at the screen. It's just downsampled to quicker get results. And some results are faster when you have a smaller image, and some results are actually better, because if the image has small texture details or grain, you just filter those away by scaling down the image. This is confusing me a lot. Didn't I just change all that? Yeah, I have to import the thing. That's okay. That is okay. Fine. Total sleep time. Okay, that's some sort of stats that we just lost. I seem to be showing that somewhere. Total sleep time. We could take this actually from the sleeper, but I don't know if it's interesting. Free and core. Yeah, it's one of our stats. Do we even print these stats anymore? I think we might not even really print them. We do, but who cares? Yes, same thing. Did I not just remove this total sleep time? Oh no, I didn't. Okay. The whole calculation is botched. I think right now we have to get without this. Oh damn it! Number of cores. What is it? What is it even doing? It's some complicated computation. We could get this number back, actually. Yeah, let's get the number back. Total sleep time. Go down. Sleep time. We could actually just ask this sleeping object we have for remaining time. That's pretty neat. You just have to put it in here somewhere. Sleeping. It's not a hard calculation, it just takes target time minus the current time. Right. Yes. Correct. Yeah. Now we have our stats back. Stats should work again. Roughly. It's not completely correct yet. Yes, I forgot the other thing. In my mental stack, I threw out the task 2 while I was completing task 1. Typical human problem. So this was task 2, putting that in there. Now compiling, hopefully. We can update Gazelle with this great update button. Yeah, we have to compile the library again. The compile times are usually nice and short. However, I have these large libraries. If I have to compile them, it's a bit slower. I don't know, what is it, 10 seconds, 12? Yeah, also I want subpixel smooth scaling. I can interpolate between the pixels of the original image while scaling down to get the perfect scaling, smoothest scale down result. I think sometimes I just have to call compile twice. Yeah, there's some minor bug. The library is only, the new version of the library is only found after compiling twice. Who knows why? Okay, let's update. Gazelle remembers its screen position now, which is really cute, really nice. Really to be expected. There's a little layout bug, but it's only because the window is so small. If, oops, no, if I do this, it appears. It's not enabled and not doing anything. And we have to restart it in order to have it do stuff. Another little bug. CPU calculation is roughly correct, I hope. 25% is a lot. Not even, I mean... No, it seemed quite benign. Yeah, this is the one. It's slightly above 1 CPU. 23%. Yeah, it could be correct. Let's not worry right now. Well, the sleep handling, I think the sleep handling works. Yeah, it's all fine for now. Let's make the scale down. I want to see this image scaled down. So we add a checkbox. Ta-da! Grid rows. We could call it, instead of grid rows, we could say just grid, and then we have a P after it, like 40p. Is that intuitive? Probably not. Okay, let's keep it as grid rows. That's good. So it's a boolean, and it says scale down preview image. And we place the control right here. A convenient function called dm checkbox. With label, no label. Which one is it? Oh, the machine is sluggish. Oh, Corona Schnelltest. Thank you. Wrong search engine that was. I think it has a label. It is with a label. The label is in the object. Yeah. With a label. Add a comment for future generations of programmers. Checkbox. Scale down. Preview image. Yeah, it's way too long though. We want a different title. Can I give a different name here? Yes, I can. Oh, it's the method signature is not so smart. Parameters should be in different order. I probably don't want to change the original function. Okay, whatever. Scale down. That'll have to do. And then we do something with it. Where is our preview image being calculated? Nowhere. Oh, we're not doing this anymore. We're not creating a scaled down image. We take the original image, just show it scaled down, like a live calculation. Image surface here. Yeah. There's no actual scaled down preview image. It's just rendered on the fly. There is one, but it just exists during the rendering, and then it's forgotten. So far this is simple. We just pass the integral image to the image surface. And the image surface is capable of understanding integral images. That's this class here. Right. So okay, one thing at a time. Oh, you can just compile first to see the new control. Update. Where is my new control? There. It's the layout thing again. I haven't found a way there. Okay, the thing here is it takes an integral image, but we want the general thing, which is an interface of an integral image, which may be an integral image that is calculated on demand. So we want to change the signature to allow the interface version, but that may slow things down if in fact we have one of these fast ones. It may be something that the machine optimizes itself, I'm not sure. But I have a cool construct that's called metaphor, not metaphor, but metaphor, which allows me to duplicate code during compile time. I think it goes like this: metaphor, this in this and this, and then some brackets, and then it will duplicate this code, substituting this for this. And I might use this here actually. I believe that is correct syntax. Almost, yeah, okay, sure. It just doesn't find the fields because the interface doesn't have fields, obviously. But it has get width and get height. Oh. Yeah. See, that's the advantage of having your own programming language. You can just have these two functions for the price of one. We write just one of them, and it gets duplicated. Yeah, that's decent. So now we can pass in this interface, and this is a virtual integral image. Meaning, if a pixel is queried, you can calculate the pixel at that moment. The whole image might not exist in memory. It's just calculated as you ask it. And for this scaling down thing, we will want to override this here. Some of these. We have one before, but it says broken. I don't know why it's broken. It looks okay-ish. Let's see why this is broken. Let's bring out the eval window where we can just type in Java Xcode and execute it. So we can make a screenshot. Shoot right screen. Ooh, shoot screen. And we make an integral image out of it. And we scale it down to, I don't know, to a width of 200. No, what am I doing? Yeah, and we show it. And we see why it's supposedly broken. Does it compile? Oh, it doesn't even compile. That's pretty broken. There's broken and there's broken. Oh, I changed the interfaces and I didn't update the function, and now it's broken. Got it. So what is our interface? Interface is this get II value. And this will also have to be extended. Right now we have integer coordinates, but I want to go to floating point coordinates throughout everywhere where images are concerned, because that gives us more precision and flexibility to zoom in and out, etc. Yeah, this channel is going away, of course. It's grayscale, it doesn't have channels, it's just one channel. It may already be the main bug we had. Yeah, okay, yeah, we should extend this interface anyway. As I said, to have floating point coordinates and floating point brightnesses. Everything should be floating point. Oh yeah, and actually it's already there. Oh no, wrong function. Yep. Integer version, both coordinates and brightnesses. Ints. Floating point version. The new keyboard is nice. Doesn't require much energy. Both coordinates and brightnesses are doubles. So the existing classes only implement this one, so this here we default to the obvious. So this should not have broken any existing code, actually. And I think the correct version here is to floor, to round down, actually. Yep. I remember having arrived at this conclusion. So did this change anything? Oh no, we have to implement our new floating point based function. And then I think the error disappears also. Yeah. I am fairly hopeful. Oh, we are forced to implement that one also. So if I put an implementation here, we can get endless loops. And we lose a warning message. If I whatever, I don't care. Implement one of the following two methods. The value of the brightness, I believe we should round. Yeah, I think it's okay. Now it compiles, but does it give useful results? Actually, it should. It's not a complicated class. No. Yeah, I want something like swappable, meaning that the parameters can be in any order. That would be a Java X extension that I could make. I have lots of these already. I have default values, multiple types for one parameter. I have lots of these meta constructs. I do not have this swapping thing yet, really. Although it wouldn't be terribly hard to make, but it always takes some time. These transpiler extensions are always a bit of work. I actually have to parse Java code fairly low level, like some sort of medium level, I don't know. Okay. I do have a helper function that swaps parameters. Oh well. Okay, there's something, but it's probably not what we wanted. This is not correct. Positions seem correct, but the color is not. Why is there this grid over my face? Is it there, or am I making it up? No, there's a grid, right? Okay, so it's not correct, but I'm sure we can make it correct. Yeah. This we don't need anymore. Integrate images based on one single lookup, which for a set of coordinates gives you a brightness value, which is the sum of all pixels from this position to 0, 0 in the rectangle. And this, I'm calculating this pixel average for an area is a function that builds on that. So all we should need here is this one function. plus the size of the image. This should define our integral image correctly. There's something with the colors, right? We didn't divide correctly or something. Yeah, and we don't have the correct subpixel calculations yet. What if we scale down less? We scale down, let's scale down exactly to half the original width. That should show us some more. 95 degrees, oh my god. Maybe we stop Gazelle. Free some CPU. Yeah. This calculation is just botched. What is happening here? The division is not correct because the subpixel sampling is not actually really correct. We can fix this one also. Let's do that one. Let's see. Get II value. We do the floating point version in our base integral image, which is actually an array of actual data. This one is pretty simple. It just grabs something from the array. Where am I? Here. Precise version with subpixel calculation, whatever, anti-aliasing. So I did this somewhere before in the audio stuff. My audio stuff I did that sort of thing. Oh, it's open already. Okay, fine. Yeah, read sum table is the similar thing to the other one. Just it has only one argument here, which is the time. This is an integral image audio, an integral audio. It's kind of funny. And I think it would be the blend function. Yes, this is the one. This is the one. Yes, that's exactly the one. Maybe we should make an option whether we use this subpixel stuff. Okay, X floor and Y floor. Yes, of course. These are integer coordinates. And first we read those. And if we are exactly at an integer coordinate, we don't do anything further, we just return the value. At integer coordinate, at one integer coordinate, perform subpixel calculation. So we need a whole, what do we need? We need 4 pixels and blend between those, I'm pretty sure. Two-dimensional blending. There's no channel because it's grayscale. Okay. 3, 4. And this would be +1 and +1, and then we do this two-dimensional blend. Do we have that? Blend 2 or 2D or blend rects, blend colors. I don't think we have this. Blend points. No, none of those are what I'm looking for. Let's call it blend 2D. And it will take 4 values. There's a square on down, blend them by x minus x floor and y minus y floor. Yeah, that's a cool function. Another cool function for the arsenal. Which other language has this? The function is so cool I will not even comment it. Leave it without comment. Then to doubles. Double x frac y frac. So we blend horizontally first, maybe, meaning 2 minus. Okay, upper value is another blend. We blend value 1 and value 2 according to xFrac. We do the same. Value 3 and 4. And then we blend upper and lower according to yFrac. Easy, right? Now we have two-dimensional subpixel calculation. I think it's correct. I may always be wrong. Yeah, something could really be wrong here, but some detail. To test. Is it better now or is it all worse? With scaling to half the size, we should not need any subpixel or whatever, because it's a clean downscale. Oh, blend 2D is undefined. Okay. Read sum table, okay, different function name. Same meaning, actually. In the audio stuff, it's called read sum table. In the image stuff, it's called get II value. Well, it's basically the same thing. Yeah. Okay, color is still wrong. We should make a class out of it anyway. This is an anonymous class inside the function. It's much nicer to have an actual class for various reasons. Fixing. Yep. So now it becomes simply a class. These become fields. Then we have a constructor. We calculate the height that fits the width. That's good enough. And we do some calculations. And these become fields. And this one as well. Yes. Missing field. Easy fix. Good. Make a standard class. Very good. And test it out. Scaled. 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 I want to print some things. Oh, don't run. I wasn't ready. I'm still coding. Let's check if these central variables are correct. Oh, I should do the right thing here. Okay, factor is 2, which is correct. I do not see a problem here. Let's show the image. Let's show it. Maybe I'll keep streaming until the software is made. Just keep doing it. Eventually people will join, I'm sure. Yeah, there's still some crazy... Okay, maybe it is just clipping. Like, it's getting out of range. In fact, yes. We are just converting to a byte, that's all. So any inaccuracy in the color computation will give a completely wrong pixel. This is also unoptimized because it scales down again, but it doesn't scale again, it just goes to the same size. So why do we need this one? Why not make a simpler version of this? Oh, it goes to black-white. It's still one more removed step. We should make that more efficient for sure. Converting to an actual displayable image, which is called buffered image. What is this one doing? The same shite. We could do something even better and return a buffered image that is grayscale. Not a color image that is actually just grayscale. In nature, but formally it is color, which wastes space, because grayscale images are 4 times smaller than color images. Yeah, I have methods for grayscale images. In fact, I think I just called it gray image. It's not the best name. Yeah, scaled gray image from this. I mean, this is close now. Yeah, this is the one I wanted. I have the function I wanted. Almost. I don't want to scale it actually. I just want to at full size so it's even faster to produce. So we just say, oh yeah, and it doesn't take the interface, it takes the direct implementation. We can fix all this. Scale any image from IPW integral image. Here. Here we do the right thing, clamp to ubyte. So anything that's too white or too black is just capped at white or black. So this all goes away, which is really nice. It simply becomes and that is still inefficient, I'm sure, because we just want a single pixel. We can say pixel sum, in fact. We have get pixel also, but it returns an int. Get pixel is the one we want. Just 1 pixel. That's it. Okay, sure. Now we use this function everywhere. For example, here, where it says unoptimized. Now it's optimized. Let's save the old one as a comment. That's that, and the same thing actually, it actually becomes the same function. In the interface and the implementation. We can just get rid of this one. And put it in here. Oh, we inherit two methods. Yeah, from the color image and from the black and white image. So we do have to put it back in here. That was a way to say, please use the implementation from that one interface. I remember that. I think just super or something. I think it was that's super, no, something like that. It doesn't matter. We call it directly. This one. Yeah, this should fix this problem, I think. We can show the unscaled image also. Checking the new function. Yeah, but it's not correct, is it? That is quite simply not correct, my friend. It's annoyingly not correct. Grayscale image from, let's see. It's very white, so it is too bright. Let's do a really small test case. Like we make a buffered image of gray with size 1, really small. And we make an integral image out of it, and we convert back to a buffered image, and we do some kind of image diff or image identical. It has to exist. Assert image is identical. Image and image 2. Yep. Missing method. We need the one that has only a height. Let's do a simple thing here. Height defaults to width. Yep, testing with 1 pixel is a good idea. So just identical. Oh, okay, some other bug here. Oh, of course. Oh, of course. That made no sense. Okay, pixel 1 is already broken. It's a very nice little test case that we should definitely save. Definitely. Test buffer Yeah, so our calculation is wrong in some way. Where's my function? Wait, get pixel. Get pixel. What about the color image? Is this also defining get pixel? No. Yes, it is. Oh, ouchie, that's bad. Let's get pixel here and get pixel in the black and white version, and they mean a different thing. Yeah, hooray. I believe this one is probably being used more. Let's say pixel brightness, actually. Pixel sum. Yep. Sure. Oh, we have another one, get pixel with a point object. Let's just be brave and rename them. I think we'll be okay. Yep. Yeah, because this is doing the color thing. I think that might have been our fix. No, wait, I have to call it here. Brightness. And let's check for any invocations of get pixel. Let's see how many there are. Quite a few. This one is using like channel, so it's color based. That's okay. I think they may just all be okay. Maybe we have some scale method. Scale. No, we actually don't. I think we're good actually. So the brightness went down, but not all the way. Let's print the structure of our particular image. Print struct. Let's see inside. JavaX can look inside of Java objects. X-ray. That's what we do here. Where is our structure? Here. Okay, 128 is the right value. That's gray. That's good. So how on earth did we get from that to this here? There are not that many steps in between. Gray image. Okay. Get pixel brightness. Let's call this one. Print brightness 0. Show me. I just made this method, get pixel brightness. Oh, I'm calling the wrong object. Brightness is 128. We are comparing a grayscale to a color. It doesn't matter image, but this get pixel method should do the right thing. Let's check it out visually. Is it gray or not? It is gray. So the image is identical function is wrong. Let's try and get pixel. Get RGB, in fact. Get RGB. And get RGB here. Come on, I just want the image to be displayed. Oh, I print a bit too much. Print the structure of a 10,000 pixel image. Okay, they are different. Why are they different? What's happening? Something with a grayscale image. But if I call get RGB, I have to get the correct grayscale value. It even renders correctly. That's just confusing. Java buffered image. Get RGB for grayscale image. Oh, is it okay? Is it a bug or is it something you have to know? If I call get RGB, I expect to get RGB colors. I'm actually not getting this, but why is get RGB not working on a grayscale image? Okay, but the image we saw was broken, so there is a bug. So let's kind of go. How do I convert to RGB? Yeah, these are the very entertaining little bug hunts. Yeah, I mean, the grayscale image is correct. Now, why does this one not work? Oh, it does now. Okay, good. Good, very good, very nice. There's no bug. Okay, I'll make a note somewhere that this does not seem to work with grayscale images for unknown reasons. Unknown reasons. This fails for comparing color with grayscale. Okay, nicey. It's scaled down, and let's say we have something odd, like divided by 3. It has to do the subpixel smoothing. Let's see what that looks like. Looks good, I guess. That looks pretty good. I want to show this pixelated. If I zoom in, I want to see the pixel. It's not the smoothed version. Not the smooth version of the smooth version. Here like this, if I zoom in, I want to see the actual pixels. Okay, now for the hard test, let's say we just make the image 1 pixel less wide, or let's say 2. The height is going to be 1 less probably, or 2 less. So it has to recalculate everything to make it 1 pixel smaller, which means most of the pixels will be averages of, or many pixels will be averages of pixels. It will be quite blurry, but accurate anyway. Yeah, this is the one, I think. If we zoom in here, we should in some areas not find anything that is completely sharp, because it has to filter in order to achieve this new width. Like somewhere around here. Where is it the worst? Oh, I said -2. Let's do -1 actually. Our factors are very close to 1. So let's check this one out. On the left it's okay, on the right it's also sharp again, but here in the middle it should be not sharp. Right? So I think you can see this here. There's always a little blur to the left and the right of everything. It's not that noticeable. It's a good scaling, but yeah, I think this is perfect. That looks to me like a very good rescale. So my blending technique, I think it kind of worked. Okay. Scaled. Yeah, this one is scaled, but it doesn't pixelate. So if you actually want to see this pixelated, let's check out the preview window here. Yeah, we should test again with the integral image aware image surface. No, this scaled one. Yes. My fridge is making some noise. I think I can put something soft behind it, between the fridge and the wall, and it will stop making this noise. I had a successful experiment in that direction before. I input, no, I image surface, where is it? Why does it need the other image for? Okay, to just to make the image surface, the base class happy. Yeah, that is not optimal actually. We need an image surface where we only have the integral image and no classic image. So otherwise, no, that's pretty annoying. It's mostly just used for width and height. Do I need a whole copy of this? Let's try to, yeah, okay. Okay. Width and height. Let's make it be happy without an image. Image surface without an image. If you overwrite the drawing, it's fine. Okay, get width. And we have the height. Replace, replace, replace. And we don't do that much other things with what? Why did I not replace this? Oh. Let's try this one first. I'm tricking the image surface into accepting a virtual image. It is used to concrete images, which are actual pixels. And now it has to handle a virtual image that is calculated on the fly. Width and height unknown, but the pixels are only available upon request. That's what the integral image is. And we override this width and height functions, actually. I always see my posture in the camera. When I slouch like that, and immediately see it. The camera should move with me. Need an automatic cameraman. So we just take width and height from the integral image, and maybe this hackery actually works. Who knows? This one we have subpixel smooth scaling. I just implemented, I think. Yeah, but that's what I just did now. Oh, it's using the concrete implementation. We need the interface here. Let's see what breaks. If anything. Nothing breaks. That's good. kind of fun to have a grayscale AI. My AI will think in grayscale most of the time. Although for the image compression and reconstruction, we do need colors. But for the recognition itself, I'm thinking grayscale. If things are not recognizable in grayscale, they are probably not recognizable in color either. So now if we zoom in, I think we should have smooth scaling. No, we don't have smooth scaling. What's this one doing? Oh, this one is calling the integer coordinate functions. We should just overwrite this. Use the actual doubles. Use the floating point. Yep. Even when I try to be loud with this keyboard, it doesn't even work. It's pretty quiet. I hope that get pixel average accepts doubles. It doesn't. Why doesn't it? Get pixel average. It doesn't because I didn't make that. Okay. I really am contemplating making a short version of the... Let's do that. In JavaX, as you know, I can rename everything. So, where do we put it? Something like bool. We have bool short for boolean. Oh yeah, unless it's a function name. That's really fancy. That's super fancy. Let's use the same one for double also. So I can still have, you know, if I write double x, I can declare a double value. But if I write anything like this, it will stay the same way. Maybe not even necessary, but it's kind of good. So tc short primitive. And but see, nice documentation. Document things for future generations. Yep, DBL short for double. I think I'm pretty happy with that. Short is good here. Okay, so look how short that becomes. The area is so much nicer to save 3 characters. Our area is a double, and these are all doubles. Exactly. So this would break, but if I use a new compiler, transpiler, it should compile actually. I just changed my language globally. It compiles. So let's check. There, downloaded the new transpiler to my ThinkPad. I think Pet is a little slow today. Okay. I thought I would see smooth things now. Why am I not? Okay, first of all, I don't actually need to scale anymore. I can just show the original image and get the smooth subpixels. But I don't. This is definitely not smooth. Okay, let's check. Our image surface is transpiler did its job, everything good. Yep, here's the drawing. Okay, I'm going to get pixel average with double values. So I am calling this one here. Get pixel sum. Oh yeah, okay, this one, okay. This one rounds it all to integers again, which we should not do. We should do a floating point version. Why this is an extra function, not sure. But I don't care, let's go here. And actually we can do this cool trick again here. We can say meta4 first int and then double. Note the new short version of double. But we could probably not use int. Yeah, no, we can use int. It's pretty cool. Look at this. Meta4. Boom, and it will replace all the ints with double anywhere. That's really decent. That's really saving on coding effort. Yeah, check it out. Int version and the double version. Duplicated for maximum efficiency. Oh, I didn't call it, forget it. I did not call it. I did not call it. Call it. This might work. I need a new sponsor. Need new income. Until the end of the month, that's okay, but after that, I need to find a sponsor sometime this month. Okay, let's zoom in, and that is looking pretty. No, it's not. Is it? Is it smooth or not? I can't tell. I think it is. It will not do, like, the stairs will still remain stairs. But if it's perfectly vertical or horizontal, it will do very blurry stuff. And actually, I think it does. I don't know if it's 100%, but I mean, this looks really blurred here. That's maybe just what bilinear subsampling is. It's just like that. Maybe we do one little test with our super simple image here. We don't know. Wait. Buffer image. Let's say we have black and white. I don't care. I trust this is working. It looked good. Let's compile Gazelle and check it out here. And then we do the cutoff. We cut off the subpixels, and so we can see the actual scaled down version. Another missing function? No. Oh, we have the library compilation problem. I was thinking I'd do just an additional transformation layer that says truncate truncate subpixels. Yeah, this one works. Cool. Forget subpixels. I don't know if truncate is a good name, but I just called it like that. Has it compiled? Oh my god, so many tabs. I guess it may have compiled. Yeah, but I do have to do it twice, like last time. Second time the charm. Yeah. Okay, I can upgrade Gazelle. And we get oh, this is old, nothing. Doesn't matter. So we simply take this double version here and just cut off the subpixel part. And that's all, basically. Simple. Forget subpixels. Gazelle is not starting. What is that? No, /run. Can't acquire log file. His database log file is probably not it. Somehow the database log file did not get deleted. Ah. Oh. Yeah, okay, if there's no image yet, it fails. Okay. Yeah. We are fooling this class a lot by giving it this virtual image. And where did it go wrong? Get zoomed. Let's get preferred size. Wait, but what if it doesn't? What if it says there's no image? Oh, there's a dummy image that we put in. Ah, I see the problem. We can fix it. So apparently it really likes to have this dummy image. But right. All right. Okay. Maybe we should put an integral image in that is also a dummy image. I don't care right now. All I want is that it works. So we can add as a standard class. There, and we update Gazelle again. Actually, it can update itself from the command line. You say, no wait, you say something like this. Yeah. Yes. It's now enabled, that's why we don't see any activity. Yeah, good. Now, if I say scale down, what is this? Another little bug. Something is not quite right here. You see this? That looks okay. %100% is okay. If I zoom in more, I get some little problem here. It's not horrible, it's just a strange line of whatever that is. Yeah, what is that? Is that an overflow? What is that? It's probably in here, right? The bug. There cannot be a bug here, this is too simple. So it's a 45-degree line. Occurs like every 8. Oh wait, where are we? 100% here? Okay. Why is it? What is it? is starting at 0. Probably. Go all the way up here. Now it's on the top, I guess. Yeah, it starts at 0. So if x and y are kind of the same value. Okay. Scaling factor is like 2. Oh, this max thing is bogus, I think. I needed this before because of the integer coordinates. So I don't take a 0 times 0 area. But now that we have floating points, yeah, okay. Yeah, we still, wait. Here I may have something smaller than 1 pixel, that's okay. What is in the truncated? No, it's all okay because I divide by the area, and the area is also a floating point. Here, and not here. Where is it? Here. I divide by the floating point area, so it doesn't matter if there's if we're within 1 pixel. Yeah, I believe it's okay actually. I declare this fixed. Let's make a screenshot. What? Screenshot of the bug for posteriority. 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 English, man. I'm never done learning it. Okay. Added work to thread. I guess that's not the most interesting message ever. This is 100%. Let's zoom in, and the bug is still there, of course. Of course. Why is everything correct? Except for this one line. How does that make any sense? How does that make any sense, really? If I zoom in more, I get less of the bug. It is like jumping to the wrong pixel there. Something like that is happening. Get II value. The original image only thinks in integer coordinates. There. Oh, yes, I know what it is. I think, I don't know. this optimization is not correct with respect to the other functions. Go through this normal way here. Oh, do you see the problem? Make a screenshot. Do you see? This is why it's a 45-degree line, because I'm comparing x to y. Yep. Let's compare x to x. That might make a little more sense. Stop making sense. Yep. Another bug fixed. So now we want it to scale down and truncate. Oh, edit work thread. Yeah, where is that? Edit. Excuse me? I thought I fixed this. Our thread pool is verbose. Should probably unverbose it. Yeah, there it is. Am I using the library version? I am using the library version. Okay. So recompile. Yes, and then we add the scaled image to the pipeline. Reserves. If scale and preview image. Nothing. Yeah, we're changing the size of everything now. Yeah. Scale down to the grid rows. Okay. Let's check the result of the other thing. Oops. Please go back in line. Thank you. check the bug. Bug is gone. Wow. Okay, we scan it through. We need the grid rows basically. Yep. And we calculate the grid covers too. Yeah, let's make a function out of it. Let's grid calls. Here, maybe. Compression. Because it depends on the image. So, wait for it. And this. Oh yeah, and I wanted to truncate. Otherwise, we won't see a difference really. Truncate it there, and I forgot the set image. Doesn't matter. Okay. Ooh. Bad hygiene. Where though? Here. Right. Just the wrong type. Scaled. We need this type, which is more flexible. You can hold all kinds of virtual images. Variable conflict. Very interesting. Okay, go. Almost there. Confused something here. I'm sure I did something strange. Yes, I did. And the other strange thing is... no. Oh, yeah. Okay. Oh, this. Okay, I think that could do it. Getting ready to update. Please update. There are some ways to fix the layout. This, now, move here. Yep, scale down, let's see. I don't see anything. I mean, yes, the green stuff disappears. That means something happened. But it's not the effect I want. Okay, that. Oh. That was one bug for sure. I mean, I could test it outside of Gazelle. Definitely. We already did all this stuff here. We just need the final touch. Truncate it. Try type. Truncate that image. But we can also update Gazelle. Give the machine a lot to do. Probably I'm going to be very choppy up here. Complete overload. Should remember, yes. It's like, yes, that's great. It's very small now because it's only 1 pixel for each grid cell. The rest is just filled in by interpolation. Okay, that's quite decent. It may have this black thing there. Looks to me like there's a black pixel that should not be there. I mean, yes, in fact, I think that's a thing. Cause there's a -1 +1 thing in the interior image formula. So I believe the correct one is not. Wait. Yeah, we are accessing. No, wait, no, we're not. No, actually, I'm not sure why it's like. Definitely has this, right? This is not in the original image. There's just one black row here, one black row there. Ray image. Get pixel brightness. Get pixel brightness. There's the +1. For example, pixel 0, 0 to pixel 1, 1. Get pixel sum. That's what we call it. Count pixel sum. Call this function here. And here it says -1. So we have -1, -1 to 0, 0. And the actual value comes from the 0, 0. Yeah, but that should work then, right? 0 stays 0. So we call get II value of 0, 0. Is it something with the anti-aliasing? Oh yeah, 0, 0. I'm not really sure. I think there's a bug though. Let's say we only have 2 grid rows. What reminds me, if you enter a number, it should immediately respond. So spinner change immediately or something. I noticed Yahoo is not as good as Google at semantic interpretation. It's just sometimes you notice that Google has more AI built in. It's that, yeah. Oh, that commits on value edit. Okay. That commits on valid edit. I have not used it before. So out of this spinner object, I have to grab something, and then, which is a text field, or formatted text field, and then I can change something. Get text field from spinner. Like this, but improper maybe. This and this and this. And this and it should be in the swing thread. There. And we can set this flag. Commits on valid edit. So spinner commit on valid edit. Oh no, we have to get the text field out of it. There. True. Okay. Ooh. Yeah, nice usability improvement. It's commit and not, wait, what? Oh, we have to grab one more thing called the default formatter. Sure. Sure. If null bailout. Let's hope that this cast doesn't fail. Still failing. Yeah, okay. You are so right, computer. This must compile now, otherwise I'm very angry. Okay. Commit on valid edit. Yeah, nice and small image here. Yep, that's our scaled down image. That's definitely the zero, but why is there this black border bug? My calculations say there is no bug, but my eyes say there is a bug. So now we have improved the spinner. I think everybody will want this. If you tap 2, you want it to go to 2 without pressing enter. Oh, that was a mistake, I think. No. Let's put it in the general thing. Everybody wants this improvement. I put it in there. Here. So the main program, so we can quickly test the effect. Oh, okay. update, of course. That's so small. Two hours and 37 minutes streamed. So now it's impossible to zoom in here. That's better. I did it! Okay, sure, good. So we have 2 times 3 pixels, I assume. No, we have 2 times 2 actually. 16 to 9, yeah, okay. We have 2 times 2. No, wait, shouldn't it round? Shouldn't it be 3? 1, 2? What's the formula? It's rounding. If you have 16 to 9, 9 times 2 is, wait, what? I can't think anymore, it's too late. I'm calculating whether the scaled down version with 2 pixel rows, it will be 3 pixels wide or 2 pixels wide. And I still can't decide. It's too late. But maybe, oh, it says actually, it's just 3 times 2. Okay, it's showing it a bit strangely, I think. I mean, here, this is clearly a pixel, and this is a pixel. All I can see is 2 pixels here. This seems like a cutoff thing. I don't think it's shown really properly, but it's because we have such low pixel count, things go a bit awkward. Let's try 4. Yeah, 1, 2, 3, it's a bit cut off. Let's zoom to window. Yeah, okay, 1, 2, 3, 4 pixels, 4 times 3, I think. 6 times 4. Yeah, no, of course it's more pixels. This is 1 pixel. Here the next one starts 2, 3, okay. Yeah, but why are these pixels black? That does not make sense. What is with this one? Is the bug here? Maybe the bug is here, in fact. The bug could very well simply be here. Let's say we use iSeal. Round it up. Let's check that one. Yeah, if that's done, that's our scale down. We can scale down our image and see how much we can still see. Because the first phase of recognition is going to be looking at scaled down versions of the image. Which, if they are very much scaled down, you almost don't see anything anymore. Whether you're a human or an AI, it doesn't matter. Just very little information. It's like a UFO video where everything is blurry. Classic. Okay, let's zoom in. No, not. That did not change really. No, that did not change. That was not the change. Do we have a new version? Right, truncate it. That's here. Okay, let's think about it. This is pixel 0. Pixel 0, 0. So I'm so confused. We could combine the scaled image and the truncation in one. May make things a little clearer. Let's make a very little nice test case. We just make a white image of, let's say, whatever, 2 times 2 pixels. Make an integral image, then we make a whole stuff. I think here is one. We scale down to 1 pixel. You don't even have to scale, we just say truncate. That's all actually. That is all. And we zoom a lot. We zoom a lot. Angry about the bug. Here's something, but it does not seem very zoomed. What is zoomed, but what is this white pixel? Something's clearly off here. This should be white, so there's actually a bug. Truncated eye. Okay. We can do a simple test. Truncate it, get pixel average 0, 1, 1. That should give us some white. It's okay to be white. Am I getting blocked from YouTube for saying that? Don't know how woke YouTube is. Okay, this is correct. That's very good. What if we take quarter of a pixel? What does it give? Gives a very high value, which does not seem correct. What about pixel sum? Or maybe my logic is actually not correct with this truncation. Sunrise. Yes, I understand why. Of course, because we're in the floating point range. And the idea of these pixelated things, truncated pixels, is that it's the same color in one pixel. So we need to take into account the exact position. The fraction matters. Otherwise we are calculating something else. So what is this actually? Yeah, I know what it is. Oh damn, I was thinking this one line would be enough, but it's actually not. So we have the, okay, explore. We can possibly reuse the explore logic. Where was it again? Oh, no. Yep. Sorry, this is the anti-inner thing, and I kind of do the opposite thing now. It smoothens everything, but what I want is not smooth. So that's interesting. So take the floor, that's okay. The exact position. Okay, we get the image, that's that. Get value at top left corner of pixel. And we can also be done if it's exactly the coordinate. And now we do a subpixel thing, blend, 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 blend. It's the same thing. Why is it the same thing? What? How can smoothing be the same thing as the opposite of smoothing? Wait. Wait, what? No, it's not the same thing. It's a different formula. It's different. It is different. Why is this so effing hard? So we have some area within the pixel we want to add. Now it's actually simpler. We go to the next one. No, it's not. Yes, it is. Now we, yeah, area is x frac times y frac. X frac is x minus x floor. Y frac is y minus y floor. This is the area we have to add. What's the pixel color now? Oh, we need the pixel color at the position. Oh yes. Get pixel, that's what we need. Basically, yeah. Get pixel brightness. X4. We want this exact pixel, yeah. Okay, pixel, the color, and then we return that value plus the area times the color of the pixel. I think that could be, oh my god. Okay, I was a bit over enthusiastic with the S's. We have 3 S's here, where 2 would suffice. Compiles, and everybody knows if it compiles, it works. Maybe. Okay, we are still at 0 here, but maybe we still have this shifting problem. It's possible. What if we go to 1, 1, 2, 2, and like this 1.5, etc. It's probably still shifted by 1 pixel for reasons. Yeah, these are better. That's a lot better. The pixel sum for the quarter pixel is a quarter of 255. The average is exactly the same as it should be. That's correct. We just simply have to like move it over by 1. I would just like to understand why. Just why? What if we are at an exact position? If we're at an exact position, we should do just a different branch here. Otherwise, we do this. Here we do the -1. We have our fraction. Yeah, that seems correct, I think. Oh no, wait. Still not convinced. Let's screw this one. It's just optimization. We just do the normal calculation all the time. Let's just try this variation and first check here. That did check. Shit. Why didn't that do anything? Ah, no. It may actually be this. Not sure I understand it, but I think this will work. Man, so much time spent on a +1 or -1, or yeah, it looks better. And now we can just optimize again, because if x frac and y frac are 0, yep, return the value. I think that could be it, actually. Let's recompile Gazelle. So what do I want to do here? I think nothing. This one was correct. Let's zoom in. That's not much different. I was very hopeful here. Clearly has a black border. That makes no sense. Oh, the black is maybe from this one pixel. No, it doesn't make sense. There's one black pixel in the corner of the original screen, actually. Where's my scale group? What? What? Come on. And what's better in here? Okay, what if I put this? Okay, maybe the scaling is causing the problem. Let's say we scale to from 2 to no wait. Yeah, it doesn't matter. Scale to 1 times 1 pixel. That does not seem right. That does not seem right. Okay, let's fix this one. The first line is already broken. We're taking the pixel value on it, should be 255, because it's all just white. Double, we have a short version of double now. Oh, we have another better function here. Format function call. Let's see, that's so good. Def debug there, and please debug. Maybe spell this right. Crack the 3 hours now. Yeah, 3 hours of streaming. Okay, we're querying this. We're querying. What is with 0, 0? Maybe this factor thing is just plain wrong. Oh yeah, I think I get it now. There's something to be done in the scaled image, I think. Yeah, because we want to query four pixels at once, not just the one. Exactly. I think what we have to do is actually +1, -1. Same here. +1 times factor -1. I believe that's the trick here. Let's check. I have such an emo hairstyle now. Because there's COVID, or there's no COVID, but there's COVID restrictions, and hairdressers are problematic right now. That's pretty neat. Why is it only 1? Yes, pixel 1, 1 is the sum of the first 4 pixels. Wow, man, I think that was the thing, actually. I also believe I have to recompile the library. No, I don't have to. Okay, I think that was the trick. Oh, man. There was 2 different changes, only one of which I anticipated. But in the end, I got them all. I think this black border should be gone now. Yeah, that's my screen at 5 pixels. I mean, it's kind of fun, right? You know, you see almost nothing, but you see something black around here, which is the webcam, something black around here, which is the chat, and something gray on here, which is the background in this window. You already see a little bit of something, but you would still have to, I mean, at this point, the recognition would say, okay, something is here probably, and something is here probably. And maybe this, it's kind of hard to see. For everything else, we need to zoom in. Yeah, now it's becoming apparent that these are straight lines. That's interesting, for example. yeah, straight line here, straight line there, vertical, horizontal. And this is already beginning to look like foreground on top of background. This here, because there's a lot of white and a little bit of gray, but you would still need to zoom in further. Yeah, that's pretty cool now. The question is, if you watch like movies and in a very scaled down version, do you see anything? You need a lot of world knowledge probably to see anything there. So here. Yeah. We could do the flood fill, which means you start somewhere and you extend your region as long as you encounter the same color. Now this is all blurry, so you cannot. You could still say I take the exact same color, check for exact same color, but find something. Maybe you want some tolerance. Yeah, that's the other thing also. Scale down control is done actually. That's good. This is actually also done. This is what I want to do now, which is reduce the number of colors displayed. I think that one is pretty easy. The thing with color reduction is it does not work with integral images directly. What you get is a regular image. Or you could treat it as an integral image, but you know that it's kind of broken. The integral image property, which is that the average color returned by the integral image for an area is the actual average color if you take the individual pixels. And if we posterize in a naive way, this will be kind of broken. But it's okay, we can keep it as a separate category. Broken integral image. Or how do you call that? Pseudo or approximate maybe. It's an approximate integral image. Yeah, if we do that, we can do posterize. Do I have something like that? I have it in this recognize a helper class, which is pretty cool. Posterize. Only 0.5 and 1. Yeah, I wanted a different posterize. To like 8 brightness levels is the one I want. Yeah, let's put it in, and maybe after that I can have a little of a break. Because I mean the to-dos are done, the sub-to-dos, which is pretty cool. So it is another selector. Yeah, int preview posterization. By default we say it's 256, which is all the grayscale levels. And here in the same spot, yeah, as I said, it's kind of a destructive operation in terms of integral images. So we would do it, I think, here. Let's only do it with a sampled down version, I think. Yeah. Okay. If posterize position, if it's not the full thing. This basically turns it back into a regular image, this one anyway. We could do something else here. Wait. Basically, every integral image is also implementation of this class, this interface, but I don't want this to have precedence over this one, but I think it's fine. I think it's good. At float pixel, here we use float. It's an older code. I didn't use double, but floats. Get float pixel, implementing this one, and that is simply get pixel. It could actually go in the interface. Hope I'm not breaking existing code. Not completely sure. Come on. Get pixel blue brightness. And here we just divide by 255. And it is a default method. And I hope it compiles. I did make such a posterization method, but I can't recall the name. Where did we do this? Interval 0 to 1 something. Quantized, yes, posterized, quantized. Yeah, I found it. Cool, there are two different versions, interestingly. Depending on which values you want to return. Oh yeah, and okay. Yeah. Quantize 0 to something like that. Posterize. We use the other function, I guess. X divided by 255, and we just multiply it again, and everybody's happy. Yep, let's test it. Quantize 0 to, let's say we have quantize 8. Mount iterator to 255. And we print a long list. Oops. Yeah, it's very precise. Has decimals. 1 color, 2 colors, 3 colors, 4 colors, 5 colors, 6 colors, 7 colors, 8 colors, 8 different colors. Very nice. I guess we can do the same thing for integers. No, it's fine. Okay, good. Yeah, so I just do the thing here. Maybe we want to look at the table here. I don't know, can optimize later. Let's say quantize, posterize, black and white image. Okay. Quantization levels. That's the variable. We just do the posterization somewhere, somehow. Say interface method, virtual image. We make another virtual image. Calculated on demand, not beforehand. Oh, there's even one that keeps the generated pixels. It's pretty cool, but it's probably not the right one. That's pretty close. Let's use this one. Posterize. Posterize. Poster. Levels. Brightness levels. If there are more brightness levels than atoms in the universe, I mean colors in an image, we return the image. Or if there is no image, then we also return the image, which is null. In all other cases, we return a virtual image. Quantize brightness levels, and it needs to be a float. And actually, it's not 0 to 2.5, it's actually 0 to 1 in this case. Levels, so looks good to me. Of course, it doesn't look good to the compiler, and he is right. He, is it a he? No. Is my compiler male? I don't even know. Okay, that's a posterized image. And finally, we want a spinner. We want a spinner. Spinner is good. Spinner with label, poster, no. Just reloaded the page, which undid my edits. Poster, what's the variable called? Yeah. Did I do this already? Or did I just undo a lot of edits? Oh my god, no, please. Yeah, I did. I just reloaded. Bit of a drawback of my editor here. It can lose edits if you press reload, which I sometimes do. Okay, here's the truncated image. If posterization. Preview posterization. I do not have this last edit anywhere, do I? No, I don't. So I have to do my edit again. So if less than this, else posterize a black white image. Ooh. In preview posterization. There. Now we want the spinner. Between, what can we do? We can do one color, but it's like kind of boring. And this is the default. And yeah, that's it, I think. Oh, compile the library. Okay. I think that might do it, but as always, computer will show whether I'm right. But this one is castable to this one, unless I didn't import properly. I didn't import properly. Okay. Mm-hmm. So it goes. I mean, here, 40p, you can already see that really looks kind of like a head. This seems to look like a button. This looks like text. You can already see stuff. There's some darker header. This looks like lines of text. Things can be seen. And then you zoom in where something interesting is happening. Oh, another import, I'm guessing. Import me beautiful. No, import's there. Huh? Come on, baby. So this extends image surface. And image surface has set image mix buffered image. And the interface we have is an extension of makes buffered image. There, and in the wait, compile again maybe. Okay. It was I have to compile twice bug. I'm so happy the compilation in general works again. I fixed the whole compilation thing with a new version of the Java compiler, a new framework. Even making the Java file is a lot faster now. Things are pretty good. Just this have to press compile button twice bug is still there. Okay, we just give it a default implementation. And that would be that then. Gray image from this interface. Using this is almost the same thing. It is just called what was it? Float pixel. And it is called get float pixel. I think we're rounding in this case. Are we rounding? 0 to 1. I think we're rounding, I forgot. Float pixel. Was it round? It was round, right? No. I can't find the right one. Float. This maybe. That's how you do it. Just convert to bytes. What does Java do when you convert to integer? Does it round up or down? It's rounded down, right? 0 to 1. No. Is it round or floor? This completely doesn't matter. It's a negligible difference in brightness. Probably less than a human can even see. And I'm obsessing about it. No wonder the project is slow. Okay, public default buffered image, get buffered image. And we call the new function. Boom, boom. Maybe it existed before, I just didn't find it. I don't know, now we have it. And we have to recompile, I guess. Okay, now I want to see my posterized colors, please. And I can call it a day. Yeah, what could be the first recognition of something? I think finding a background or something that is a rectangle or almost rectangle. Here we have a black rectangle with the foreground stuff. Here we have gray with foreground. Here we have white with foreground. Here we have black with foreground. Finding that, I think, is a good first recognition step. Come on. What did I not? What? Remember? Compile twice. After the library changes. Yeah, now it works. Okay, now please, I want to see some posterization. There's our control. It's not enabled, so let's do that's one thing. Wait. It's unable to reload itself because I don't have the operating system running. I have a super simple mock-up of the operating system. So this used to be a module in my operating system, and now I'm faking the outer part of the operating system. Almost nothing left, but we need a few functions. Reload module in background. And I think it takes, what does it take? Reload module. I think it's a direct reference to the module. show this actually. And we simply restart the whole program, which I already have a function for. Okay. No. No, it takes the stem as a module, and there's a stem, which is the anchor point of a module in the operating system. And there are technically different things. Okay. Yeah, now it restarts the whole program. When I say enable. Okay, now we have some content. And let's check out web posterization. How about 2? Yeah, that is black and it is white. And this is 3 colors. Black, gray, and white, but there's very little gray. Maybe it's normal. 4 colors, 5. Yeah, the rest is very bright, so there's not much to gain here, but many colors, interesting. While I was thinking about it, like in my head, not coding it, I was thinking 8 could be good. 8 brightness levels sounds interesting enough, while also being simple enough. It's funny that there's so little in the middle. There's some down here. Okay, 8. And now we could start going through, and we have exactly the same color in many cases because it's quantized. So we can make a region out of this, flood filling it. We should really get this whole white thing. Definitely, if we go a little more detailed, we will then be able to get this white area. Something like that. Let's just make the names a little shorter. Can I choose my label? I'm sure I can. No, I cannot. Yeah. Label default humanize label. Humanize, nice name, right? Just has the spaces and capitalization and stuff. Posterize, and the other thing, what do we call this? Grid rows. Let's just say rows, and scale down. We keep a scale down. The window is only so small, so I can fit it here on the general stream setup. Normally you would have like this size, I guess. Yeah. That's very good. I want to check out some like live action video to be analyzed here, but I don't know what to show right now, and it's got to be copyright free and whatever. So doing that next time. But yeah, we got the controls implemented, and now I really want to find some things. What if we could scan the whole Discord window, for example? Find all the avatars and the servers and controls and stuff. Yeah, this is this is perfect. For example, here we can say we can find out it's a rounded border, rounded rectangle, like a 1 pixel border of some color. Inside is white. We can mathematically describe this. This is one line and another line, both of width, I don't know, 2 or so, depending on how you look at it. No, it's actually width 2. Yeah, that's the correct description. And if we even have a symmetry operator, we could say this is this line plus symmetry. So that would be even more compression. Here's the same thing. This is symmetry plus different color. Or we just detect these 3 lines here, and this is a different set of 3 lines. But we should usually be able to reproduce the image exactly, even with this anti-alias that they have in the original icons. There must be a formula for this, so we find the exact formula actually. We can replicate user interfaces pretty soon. Just to have a look at the user interface and it will be replicated by Gazelle. Pretty cool stuff. Okay, thank you. Bye bye.